Hi all, welcome to the SDC India 2022 version. So today's topic that I'm going to present you is regarding design challenges and their appropriate solutions, focusing on unstructured data management platform. So myself, Anand Reddy, I work as a platform and performance engineer with a startup called as Komprise. Its specialization is regarding offering of unstructured data management offerings to our customers. So let me just walk you through the coming 20 minutes of the challenges that come while working, architecting, or developing this kind of unstructured data management platform. So just to give some context, so what can be typically classified as structured and unstructured? As you can see that if you take the survey, nearly just 20% of the data that is being available or produced would be classified as structured data. And the bulk of the other data, which typically is being generated by users and applications in the current data center, is going to be unstructured data. So this unstructured data typically doesn't fit into the bracket of rows and columns or kind of relational databases. And you would have more kind of formats like listed here. There will be more of text and files. There will be server logs, there will be sensor data, there will be genomics data, images, video files. So everything that you can visualize from social media, everything can be categorized as unstructured data. Now, why the buzz currently on unstructured data? Why should one bother, or what is the key concern around unstructured data is? As you can see, the chart above, so the data growth is exploding, like we all know. But are the IT budgets really holding up with that? Not really. The budgets are still very stringent, and as a storage infrastructure enterprise, one needs to keep a close watch on what is the utilization of the storage servers and how we can better optimize this. So you can see in the last decade or so, the rate of growth of unstructured data has been exponentially high, whereas the structured data more or less has been a little bit linear, to say. And also the organizations are realizing that we cannot rely just on on-premise hardware or the storage procurement. And most of the companies are tending to incline towards a multi-cloud or a hybrid storage management that we can see. And with this, what is required by the companies and the customers is they need efficiency, at the same time cost savings from this unstructured data. So hence the requirement of the industry is to have a data-driven or a globally managed dynamic unstructured data, which spans both cloud and the on-premise storage infrastructure. So we can also note that, the people who have been in the industry for a while, that the definition of the locality or the topology of the storage itself has been changing over the last couple of decades. So what used to be inline and offline earlier is not the same today. If you see inline data or the hot data or the data that is being used or accessed frequently would be classified as inline. And typically this kind of data would reside in the hot tier or the disk or the SSDs. And anything non-hot data would typically go to the tape. But today, if you see, the ecosystem has evolved significantly, and you can see that the hot data is no longer just confined to disk. It's there in the flash, it's there as a disk, it's there on-prem NAS, it's there as a cloud NAS, and to some extent, even the S3 objects is being leveraged both for hot or inline as well as offline data. So with this kind of categorization, you can imagine the customer's pain that would go into handling the unstructured data for their optimal use case. So what are the industry veterans doing? How are the companies coping up with this? So it is not a very new problem. So this has been there for a while, and there are many players out there who are trying to mature their architecture to stand up to this. So there are both established players, and you can see the startup vendors as well. So one of the leading player there is Komprise, which is what my current employer is. And I will talk regarding how the architecture that is developed within Komprise to handle this kind of unstructured data management challenges. So typically, just to give a brief introduction of what Komprise does. So like we have given the context, what is unstructured data and what are the complexities that come with unstructured data. So Komprise as a solution is a single platform, a SaaS platform, and that serves multiple use cases. As you can see or imagine with unstructured data, you would need to monetize this data. You would need a transparent archival. You would need an efficient migration platform. You would need it to be AI ready, right? So all the data that you are producing or being storing as their unstructured data, they need to be put into use for AI ML kind of use cases. And that is why you need to have smart data workflows, which will allow us to go to that kind of use cases. And another thing, as you can see on your left, is it can ingest data from multiple data sources. The data sources can be on the edge, it can be on the clouds, or it can be in the data centers. So as you can imagine, the data comes from multiple sites, and one need to really have a global view of this, or kind of global file index, and then take the appropriate corrective action to either tier it to a relevant storage tier, or migrate it to an appropriate filer, or make other use cases to pump it to data lakes or big data analytics kind of platform. So what is the advantage that customers keep coming back to Komprise? As you can see, some of the benefits are: there is no hardware dependency, there is no vendor dependency, there is no hard lock-in with the vendors. We work very well with multiple NAS vendors as well as the cloud storage vendors, both on-prem and off-prem, I'll say, even the S3 vendors out there. So you can see there is a mixed catalog of vendors that we support, and this truly makes Komprise a very flexible choice for the customers and a very intelligent choice, and that's why we call it as Komprise Intelligent Data Management Platform. So now let's talk something about the architecture, right? So if you see a very high level, a bird's eye view of how the architecture today is, a very oversimplified architecture is. So Komprise has an internal stack comprising of Komprise Grid, which can be thought of as a data mover. So just attach or plug all your sources, which can be your NAS filers, which can be your object stores, or the S3 objects in the cloud. And once this grid, a Komprise grid, talks to these data sources, it quickly comes up with a global metadata related file index, which can be centrally visualized from the Komprise director, and then appropriate data management actions can be taken upon this data. So good thing is there are no agents, there are no stubs in across all of these data flows. The transparent data is not being coming in the way of the hot data path. And once these objects are available to the user as a native object in the S3, they can be directly accessed without having to come via the Komprise stack. And it is truly scale out in the sense there is no single point of contention or bottleneck being introduced. So that makes the solution truly scalable. But the key takeaway here is, why are we showing this architecture is, while working, or even from a performance engineering point of view, when I get to work on these modules, either for validation or baselining, there are some of the common attributes or some of the common design challenges that we come across. And I try to list them and try to categorize them for the users attending SDC India. They can maybe use it as a template and see if they can also implement in their data management platforms. So one of the simplest thing can be, if there are customers who are opting to use Komprise or this unstructured data management platform for a simple use case, like not simple, I would say a very recurring use case like data migration, you can visualize that workflow in this case. So you have customers who are residing in the existing old NAS file systems. They can be both SMB or the NFS protocols. And then they would bring in something like Komprise here to help orchestrate and simplify the data migration operations, right? And then you would have the new NAS being brought up accordingly. And this is what a simple data migration would look like. And as simple as it looks, there are multiple design concerns that come with this. And let us see what are some of those. So what the architecture expects, or what the end business would expect, is the data migration should be seamless, it should be fast, it should be very optimal on the resource usage, and there should be minimal downtime while we do all of this data movement. So what are some of the key parameters or design goals we can call it as for data migration? If you see, one needs to ensure that throughout the stack, there should be parallelism. There should be parallelism at every layer so that all the available resources are made use optimally. And then when we are talking of protocols for migration, then needs to be minimal protocol overhead. It should not be that users migrating from NFS or SMB in one filer onto a different filer have a lot of protocol chattiness. So those kind of things need to be minimal so that data migration is seamless. Next thing is, it's not just enough to have data being migrated. There needs to be a fidelity or a MD5 checksum done on every file that is moved or every object that is moved, right? And this needs to be the ACLs or the permissions and the metadata needs to be preserved while this migration is happening. So this is some of the common requirement that comes. And additionally, for simplifying the user experience, right? If there are any glitches or bottlenecks or the migration is broken at some point, there should be a very reliable retry mechanism in place for the migration to be seamless. So whatever the PM comes with the requirements, whatever enhancements, whatever customer inputs are taken. So these are some of the common design requirements as an engineer that you would have to ensure, whether it is any kind of protocol or any kind of filer migration that we are doing. Now, having said this, so what are some of the things as an architect or as a performance engineer you would be watching out for when designing such a stack? So in order to accomplish the design goals that we just discussed in the previous slide, some of the common things that we need to ensure is to get the best out of the architecture is, can we bring in the elastic migration concepts? So what this means is, for a simple migration, you would be migrating the shares from one filer to another. But can you ensure that it is more elastic and the data modes that talk to these shares or mount these shares, they are not just being contended by the capabilities of a single data mode, or they are not being just hanging on to the crawling that happens while scanning the file system. So if the crawling and the crawling operations can be distributed across the multiple data modes, we can expect that you can call it as elastically we are scaling the migration architecture. So this is one of the ways that we need to keep a watch on. And then the second block that you're seeing is optimized RPC or the TCP stack. So as we know that for the NFS or NAS migrations, we do a lot of communication over the RPC for the NFS v3 in this case. So you would see that multiple RPC connections can be leveraged wherever possible and not really be limited by one RPC call for a given migration use case. So when you can analyze this over a Wireshark and see whether your existing data migration suite is really optimal or there is a lot of chattiness or the protocol overheads coming in. So probably you can also think of optimizing or minimizing the calls over the stack to ensure a faster migration. And then we are talking of migration. It is not just on-prem migration. You would have cases where you would have majority of the cases, at least in the coming days, where customers are interested to migrate from an on-prem NAS to a cloud NAS. This is where the MAN migration, the third block that we are seeing here, needs to be factored in. So what MAN migration means, the users want to free up their on-prem filer and move to their cloud NAS. And what happens in this case is the placement of the data modes itself or the placement of the architectural blocks that are being used in migration needs to be carefully watched for. So there can be a chance that placing the data modes near the on-prem or the target might make a big difference. And why this happens? Because when you see the first migration is typically the heavy migration where the bulk of the file movement happens, and maybe the subsequent migrations will be more change block or the iterative migrations will be more just based on the change rates that's happening in the file system. So when you see the first iteration or the first migration is where the bulk of the data is being copied to the target. So it is better maybe as you can test and validate that your data modes are better placed near to the target. And for the subsequent migration, you can have them brought up near the source. right? So this is one approach of optimizing the WAN migration. Of course, it depends on use case to use case. It depends on your nature of the files, the structure of the file system itself. But this is one of the common thing that one can look for optimizing their migration use case. And the last one is again, one of the key thing for any migration in the data management or unstructured data management platform, there needs to be a heavily invested time and resource for perf baselining. So something which can be measured can be improvised. Something which cannot be baselined or not measured are really difficult to optimize, right? So measure what are the files per second or the bandwidth that is available for migration. See how much you can push over the wire and what is the overhead of the protocol based on the varying file sizes, based on the varying data structure itself or the folder structure itself. So ensure that you're saturating the bandwidth to the extent possible so that the migration is completed in the least amount of time. Similarly, the next use case can be thought of as, other than data migration, users come to us for data archival. Data archival is like all the file systems that are there today on-prem or other filers. And if the users feel that these files have not been accessed recently, and we have a strong data that typically 70% of the currently utilized file systems have data which has not been accessed in the last 1 year. So with this kind of infrastructure, a lot of sense is there to migrate this to a better or a cheaper object stores, either as a private cloud or as a public cloud. So this has been done by various storage vendors as well. But the thing is, they are more aligned to their local architecture. But what Komprise helps is it removes a vendor lock-in from the system, and it helps you seamlessly archive from your filers to the cloud without having a vendor lock-in. But what are the typical recurring issues or recurring architectural concerns or design goals that come up with this kind of platform is, we need to ensure that the archival data transfer performance is not becoming a performance limitation. So the overall impact of transferring or archiving the files, we kind of want to limit it to, say, a boundary figure of 5%. And then when we are working on so many files or file systems here, you can imagine the amount of indexing or amount of scanning the metadata that would happen across these file systems. So you need to ensure that your design has sufficient knobs to ensure high speed search functionality as well, because users typically want to ensure the files which are not accessed, only those files to be moved to the cold tier from the hot tier. And that's why your internal crawling algorithms should be very performant to support this kind of ecosystem. And once these objects are transitioned to the cloud or the cold tier, there will be a definitely use case where customers want to sometime, for whatever reason, come back to your system and say, I need a read access or I need a write access for this file. So cloud native access should be one of the key goals for your data archival platform or unstructured data archival platform. So keeping these three design goals, let us see what are the recurring ways or smart approaches that one can take for optimizing the data archival solution. So first thing, get the best out of your crawling design. Crawling has to be seamless. It has to work from files ranging up to billions of files across the folder depth. You can use multiple algorithms or custom design choices within your company. It can be proprietary or it can be patented ones, but there needs to hold up to this kind of scanning running into billions of files. And you can check the responses, that how is the system behaving for limited file shares or even thousands of file shares when they are exported onto your data modes. So as you can think that the archival is not just limited to one file or one share, it will span across thousands of shares in your data center. And also check if you are scanning too many small directories, what is the impact itself on your data modes. That kind of may be a limiting factor based on the directory depth. And some of the common concerns can be, if the files are already being used as symbolic links, ensure that when you're scanning it, you don't end up duplicate analysis there. So you need to already ignore or consider that files can be symbolic links, and that has to be discarded from your primary analysis. So all in all, so optimizing and crawling design is one of the common pain point that one needs to attack first. And then once your crawling is in place, so what happens for the data transfer stack? So classify your whole operation into at least 3 categories for an archival use case. So what is the discovery time, whatever time you spent in crawling directories, and then add that to the file transfer time, like just to get the file handles, what is the overall overhead coming, and then the data transfer time itself, that is the actual data transfer on the pipe. So once the crawling is taken care of, then if you are able to optimize or better your data transfer stack, that will really be a next smart approach to figure out in the architecture. And then you would come across multiple places where throttling has to be considered. So throttling, though one might think that this is the easier or the most common recommendation, but then throttling has to be taken very cautiously and not done indiscriminately. So in your architecture, you would see that there are use cases where you may throttle, there are use cases where you may never have to throttle, and there are use cases where your architecture definitely has to throttle. So throttling has to be considerably taken care in your design. This will help you to achieve a better and faster archival mechanism. And then once all these files are archived, right, like we discussed, the access performance is where the customer's experience will be determined. So once these files are archived, how easy it is or how seamless it is to read this or even write to the files that were archived. Yes, so even the files which are archived, customers may want to come and overwrite those files, which is what the cloud native read and write access has to be guaranteed in your platform. So as you can see, these are some of the recurring design challenges and some of the approaches that one can think in optimizing your data management platform. So we just thought we'll share these pointers, and this can be reused in the audience who is designing or developing, architecting or working and validating the data management platform. So that's all I had for this short, brief 20-25 minutes discussion. I would appreciate your feedback, if any. Thank you for listening, users. Have a good day.